Welcome to What the Fuck Biology. Last episode, I asked my guest Sneha Vissa if there was a scientist who changed the way that she thinks about science. She talked about her undergraduate professors and how important they were to her personal development as a scientist. If you missed that episode, go back and listen to it. Sneha and I had a great chat about the critters that get carried around on mountain pine beetles and what that means for the forest health of Western North America. Like Sneha, I also maintain friendships with many of my old botany professors from undergrad. In fact, we heard from one of them in episode 2, What the Fuck Biologist, Rachel Carson. If you missed that one, go back and check it out. It's such a great episode. My guest and I discussed the life and legacy of Rachel Carson. The full interviews of 4 of the guests are available on Patreon at patreon.com/WTF Biology. For just $1 a month, you can get access to not only those full interviews, but a bunch of other awesome bonus content. Your support makes this show possible, so thank you. For this episode, I decided to play the full interview of Dr. Gene Bozinak that he and I recorded for the Rachel Carson episode. Boz, as he is called by students and faculty alike, is a retired professor of botany at Weber State University in Ogden, Utah. Boz has a superpower. He can make a person question their belief system and confront their assumptions without offending the person in question. There has been some people that do take offense to be calling a Zeuschauvinist, but I think that most people walk away from conversations with Boz realizing, probably for the first time, that they have biases towards certain life forms at the expense of others. Boz and I talked a lot about biases, but lots of other stuff too, like how snail parasites connect to the Soviet Union, and how the Christianizing of Europe resulted in ecosystem destruction. So now, Gene Bozinak. What the fuck, biologist? Thanks for doing this interview, Boz.
You're welcome.
Can you state your name and what you do?
I'm Gene Bozinak, and I'm a retired botany professor after teaching for 45 years at Weber State University.
Which is where I did my undergrad.
Uh-huh.
You designed a class called Environmental Appreciation, right?
Right. Should I give you the genesis of the course?
Yeah, that would be great.
Okay. It has to go back to the decade of the 1960s, which was a fantastic decade for environmental awareness. That was a formative decade for me because I left high school in 1960 and I came away at the end of that decade with a PhD. So it was very formative for me. And I did my PhD work at Washington University. And the chairman of the Department of Botany there was Barry Commoner, who was very influential in my development. He was, Time Magazine did a cover story on him and called him the Paul Revere of ecology, even though he wasn't a trained ecologist, but he was an activist and very sharp and, like I said, very, very influential in my development. And he inculcated in me an interest in environmental awareness, and that's what I brought to Weber State. When I came to Weber State, folks knew that I had some background and connection with Barry Commoner, and so they said, why don't you develop a course in environmental science? And I said, I don't want to do an environmental science course. And they asked me why, and I said, I felt that environmental awareness had to be broader than just environmental science. It wasn't just scientists that were contributing to decisions, but other disciplines as well. So in making the evolution from environmental science to something else broader than that, I thought, why not environment appreciation, using the noun, not the adjective? After all, there was an art appreciation class, a music appreciation class, and I thought, why not environment appreciation? Because therein was the crux of the need for environmental awareness. We didn't appreciate the environment enough. Obviously, understanding the environment was key to appreciating it. So I could contribute from the science end of things, but I wanted it to include other disciplines and subdisciplines from the humanities, from the social sciences, from engineering, virtually from any discipline. I felt that they had a stake in assessing environmental problems and contributing to solutions to them. So that's why the Environment Appreciation course was named as it was. So that was the class that began in 1971, and I taught it for 45 years.
Yeah, that's a great story. I never actually knew where it came from. I knew how influential it was for so many students, but I didn't know that that's how it came to be.
Well, it was influential for me too, because I had a chance then to espouse many of the things that Barry Commoner taught me and others.
So you've literally educated thousands of students about appreciating environmental issues.
The 1960s, as I said, was a very important decade in the history of the environmental movement in this country. That was the third wave or peak of environmental consciousness awareness in this country. One was in the 1800s. It took a long time to develop that one into the start of the 20th century. And then it ended with the First World War. World wars tend to assuage interest in environmentalism. We had the second one during the 1930s, during the Dust Bowl. We had a lot of species that were, I recall the story of the passenger pigeon in the Midwest.
Oh, yes.
Huge flocks of passenger pigeons that were market hunted. And we didn't think that we could ever hunt them out, but we did.
Yeah, and these flocks, when they would fly by, would block out the sun for hours.
Exactly, and we thought there's no way we could have a significant impact on the numbers of the passenger pigeons. But in a few years, those flocks disappeared, and the last passenger pigeon died in the Cincinnati Zoo. Well, so there was a second peak of environmental consciousness in the 1930s, and then that ended with the Second World War.
Right.
You know, when it comes to a world war, we all hands on deck and conservation be damned. We need resources. So this third peak was an interesting one. That was the one that started in the 60s with Rachel Carson's 62 publication of Silent Spring. And as I mentioned, there are other publications that came along in that period that launched this third peak of environmental awareness. Unlike the other wars, there was an important war in the third peak that didn't squelch our appreciation of environmental issues, but instead enhanced it, and that was the Vietnam War and Agent Orange. That's when the environmental movement became kind of an awareness of environmental health issues, and that was an important aspect of the environmental awareness.
Yeah, because that Agent Orange, it could decimate huge areas of tropical rainforest, right?
Yeah, and that's what it was designed to do. It had no idea what it was doing to humans.
Turns out it was causing leukemia, heart disease, lymphoma, birth defects, and all sorts of other long-term health problems. The Vietnam government estimates that 4 million people have been affected by Agent Orange. There have been tons of legal action against the U.S. and other governments that use the herbicide. About 12,000 square miles, or about 31,000 square kilometers, for those of you that like easy math, of Vietnam forests were destroyed with Agent Orange. This toxin bioaccumulates, meaning that it is magnified roughly 10 times at every step of the food chain. An estimated 1 million Vietnamese are disabled due to Agent Orange use still. Birth defects happen more than twice as often in Vietnam than other parts of the world. So yeah, this stuff is really awful. This unintentional experiment showed us that the shit that we spray around kills stuff, even humans. And people were not okay with this. Agent Orange kept environmentalism in people's minds even through a war. And that might have even helped fuel this third wave of environmentalism that Boz is talking about.
It was started by Rachel Carson with her Silent Spring in 1962. But there were other folks that were equally influential in that decade, including one of my mentors, Barry Commoner. Commoner wrote a book called The Closing Circle, which he published in 1971. we had discussed a lot of the content of that course, both informally and formally with Commoner in the middle part of the 1960s when I was working on my PhD.
That's excellent.
And he would bring in other folks like Paul Ehrlich and Ian McHarg, who would also publish influential books in the 60s. So it was an interesting period in this country's history. And so I was happy to have an opportunity to discuss many of these ideas in that environment appreciation class.
Awesome. Okay, so basically what was kind of the structure? What were like the learning objectives of this course?
The first third of the course easily was non-science, and it took me a while to get over the guilt of giving life science credit for something that I was not teaching. Basically, something broader than the life sciences. And so my thinking was I would draw on resources, faculty resources from across campus in other disciplines after I told them what I wanted to achieve in the course, which was basically an awareness of environmental issues from every disciplinary view possible. And where people didn't think there was a connection, there always is a connection between whatever it is they do and assessing environmental issues and coming up with the solutions to complex problems. So the first third of the course was the objectives were simply to broaden the awareness to include disciplines and subdisciplines that people didn't think had a stake in environmental issues. And so we discussed issues like perceptions of nature by humans, the inclusionist versus exclusionist thinking or philosophies, and how that has evolved over time. The critical need to have us start thinking about humans in nature rather than humans and nature. Doing things like discussing the quality of the environment. Can we define the quality environment? Those sorts of things. And, covering the history of the environmental movement. Where did we get our ideas? And how did they evolve over time? A lot of folks, a lot of the students at that time felt that this was a very new thing. Well, it really is.
Right.
Environmentalism, ecology is older than the term ecology itself.
That's right.
So I think it behooves us to take a look at that history. So we went back to biblical times in discussing the view that humans had, and as recorded in the Bible, the meaning of wilderness, for example. In the Old Testament, there was something like, and somebody's actually gone ahead and counted references to wilderness in the Old Testament, and they came up with a count of 245 references, where wilderness is regarded as kind of an inhospitable, ugly, life-threatening environment, something to be feared. Well, in the biblical context, that was true of the desert. If you were banished to the desert, particularly if you were bad and banished to the wilderness, you may not survive.
Right. It's basically a death sentence.
But things started to change. In the New Testament, apparently, there are only 35 such references to wilderness as being inhospitable. And then we talked about how that idea was taken to Europe during Christianizing of other parts of the world, and the idea of wilderness in the European context, particularly in Northern European context, was the forest. Forest was wilderness, and it was where evil lurked. To this day, we talk about where does the big bad wolf reside.
Right, yeah. I'm thinking back to all the Disney movies of my childhood, and you're running through the forest, and there's these gnarly trees that are going to jump out and get you.
Right. And one of the things that I like to point out to students was that the forest was wilderness, and in the wilderness is where pagan rituals took place. And if you were going to Christianize a pagan society, the way to do it is to destroy their temples. So you destroyed the forest. We've done that throughout history. You destroy people's temples, and so they have nowhere to practice their religion.
Right.
If you wanted them to change that religion. So that was Europe. And the seeds of environmentalism were actually sown in Europe before Europeans came to North America. We like to think that North America was founded by Europeans who developed this rugged individualism that we're so noted for.
Indigenous people have been here for tens of thousands of years before us white people showed up and started fucking things up. Recently, I was sitting in a Zoom meeting that we're all sick of doing, and I was listening to a leader of the Zuni tribe talk about the cultural importance of the Zuni River and how the white man's greed has stopped the river flowing. The Zuni people's gateway to Zuni heaven is found at the confluence of the Zuni and Little Colorado rivers in Arizona. The Zuni River has been dammed, which has stopped the water from reaching the Little Colorado River. Now the Zuni people have no gateway to their heaven. We ruined that. As this Zuni leader was talking about how the politics and economics of the white man have prevented his people from reaching their afterlife, I was thinking about religious competition. In order to get a person to change religions, all you gotta do is destroy where that religion is practiced. That happened in the forests of Europe when pagans were Christianized, and we've done that here in the Americas too. We've destroyed their temples, which are really natural ecosystems, and we've left millions of people stranded. What I learned from that Zuni leader is respect and preservation of our fellow man and cultural diversity also means respecting and preserving natural resources, not to be exploited, but to be reverenced.
And this land seemed to be, in terms of resources, so plentiful. There was no way we imagined that one day we'd be talking about destroying large tracts of this wilderness. But indeed, we did. But
right.
There were folks in Europe that were drawing attention to wilderness issues and environmentalism in terms of the seeds of environmentalism. I like to point out the French philosopher Jean-Jacques Rousseau, who wrote an interesting book in 1754 called Discourse on the Origins and Foundations of Inequality Among Men. And he wrote then very much like people were writing in the 1960s. He challenged the belief that better technologies, material wealth, knowledge would lead to improvement of humanity and morality. Again, a lot of the early environmentalists thought that way, and we're talking about 18th century Europe. So it isn't as if we discovered or invented or developed environmentalism in this country or in this continent, but that wasn't the case. It was always there. So this duality between environmentalism and rugged individualism and exploitation of resources has been there right from the very beginning. And the pendulum swings from one to the other, in a sense. General education courses, we had to fulfill certain kinds of outcomes, make sure that we had addressed those since it was a general education class. So it was, there were some basic fundamental biological principles that we had to cover. But I always took the approach that we needed to bring that into the environmental context as much as possible, whatever the biological topics happen to be.
Because it is important to put these issues in their proper context. And
exactly.
So I know that when I took that class as an undergrad, I was a geology major. And I kind of wasn't really happy in geology. And I was kind of like, this stuff's interesting and it's okay. And I took environmental appreciation and I was like, holy shit.
Yeah.
This is so awesome. And like that day, I went to the botany department and changed my major. And and I really credit that course for setting me along this path in academia to study botany, which got me to go on to to do my PhD, which hopefully someday I'll finish. It really launched me. So thank you so much for having that be such an important class.
Oh, you're welcome. And I felt that was a good vehicle to get students to be turned on to environmental awareness and want to learn more about the science of the environment. And so it became an important course for recruitment from across campus.
Yeah, I certainly know that there's a lot of people in the botany department that's exactly what happened. You roped them in.
I still have people in the community that say, I took that class 30 years ago, and there's one thing I remember about that class, and that was when you said that there was no such thing as a way. And they said 30 years ago you said that, and I still think that.
Yeah, so what does that mean? There is no away.
Okay, well, again, this basically comes out of Barry Commoner's closing circle, because he tries to, and I give him a lot of credit for taking fairly difficult concepts, biology, and communicating those to lay people. He was very gifted at that, and I felt that I needed to follow that kind of a pattern if I could. And so I talk about laws of ecology. These laws would be laws as if we were talking to lay people. I distilled everything I knew about ecology into 4 general laws of ecology in layman's terms. The first one is that everything is connected to everything else. Okay, and then I would spend probably 3 lectures on these 4 laws of ecology by way of examples. Everything is connected to everything else. And I tried to come up with some somewhat obtuse examples just to get students to think. For example, I asked the question, what is the connection between, if everything is connected to everything else, then there's a connection between any 2 apparently disparate things. And I said, what is the connection between Soviet foreign policy and schistosomiasis? And first of all, students would say, what the hell is schistosomiasis? So we'd have to discuss that. And I said that it was, another name for it is bilharzia, and it's very common in the tropics, a disease that many people died from. And it's associated with snails. Snails are an intermediate host for this parasite. But then students will say, well, there's no connection between that and Soviet foreign policy. And so the answer to that was that I was getting at the development of the Aswan High Dam. The Egyptians wanted this dam built, and they shimmied up to the Soviet, and the Soviet engineers built the dam rather than Western engineers. So when they built the dam, they stopped or slowed down the flow of water in the Nile and its tributaries, and that the snail population exploded, and we had an outbreak of schistosomiasis and killed a lot of people. So the connection was schistosomiasis habitat exploded with the construction of the Aswan High Dam, and so there was a connection between Soviet foreign policy and schistosomiasis. Okay, so that was the first law of ecology. The second was everything must go somewhere. There is no away. And I would tell students that I'm not for censorship of anything really, except I said if I had the power, I would do away with that word away. I'd go in every dictionary and rub it out so that we wouldn't use it. Because there is no such thing as away. You don't throw anything away because there is no such place or thing.
I think that Boz appreciates the irony here, doing away with the word away. I took marine biology from Boz as an undergrad. We had to give this little presentation about some topic. I chose plastics in the ocean because, hey, there will be lots of information about that. And yeah, there was lots of information about that. It was also so depressing. So keep in mind as you put your groceries in plastic bags or you drink from a plastic straw that there is no away. Many countries, including Canada, hi Canada, I miss you, are developing strategies to eliminate single-use plastics.
And so lots of examples of that. For example, and the one I used extensively was pesticides and that accumulation in biological systems. What Rachel Carson was talking about in Silent Spring is biological magnification. And students need to understand how that takes place. How is it that DDT or any molecule that meets 2 important criteria, one that is not broken down or metabolized by the body, or excreted by the body. And if you get something like DDT, which was fat soluble, it's going to get absorbed by the smallest of things, algae, and then through the food chain it goes, and it gets concentrated about 10 times with every trophic level transfer. A little lonely alga picks up a molecule of DDT, stores it in its lipid membrane. Small zooplankton eat the alga, and they have to eat 10 times the amount because I use 10% energy conversion with every energy trophic level transfer. as kind of the average. Many organisms are above that and many are below that. But using 10% so that math comes out fairly obvious. And so they accumulate all 10 molecules of DDT because 90% of what they consume is lost in terms of heat or waste. Mm-hmm. And so there's a 10-fold increase in the amount of DDT in the small zooplankton, which are fed upon by large zooplankton. So you have another 10%. Mm-hmm. Small fish eat the large zooplankton. Large fish eat the small fish. And finally, we eat the tuna. And lo and behold, we have high levels of mercury in our tuna. Right. Or mercury or DDT or whatever, as long as those two criteria are met. And so, like I said to the students that, we used to throw mercury into the ocean and, then 4 years later, we'd serve it up as a mercury sandwich.
Would you like mercury or DDT for your lunch?
Right. And third law of ecology was nature knows best. Mm-hmm. Again, lots of examples of that. And the fourth law, in layman's terms, was there's no such thing as a free lunch. There's always a cost involved. And that also holds for economics. It's sort of a law of economics as well. There's no such thing as a free lunch.
Right. I think economics and ecology are very interlinked.
Exactly, and that's why I used to really enjoy a lecture from Dr. Richard Alston, who's an economist at Weber, and he was a feisty, controversial guy, and he'd come to the class and say everything that Bozinak taught you is all crap, and let me tell it like it is. And the students wondered why I would keep inviting him.
Right.
But we had a great relationship, and we, it was thought-provoking, and I would search out faculty that were thought-provoking. That was important to that class.
Certainly. Yeah. That was one of the foundational classes that taught me how to think like a scientist.
Uh-huh. Healthy skepticism is very, very important.
Yep.
So, and then, of course, I would get on bandwagons like my primary production lecture, Zeuschauvinism.
I wanted to ask you what Zeuschauvinism is.
Okay, well, some people used to call it plant blindness, where we talk about natural ecosystems and forget that plants are even involved in them.
Even though they're the foundation.
Exactly. And I think most biologists are guilty of perpetuating a good deal of that bias. And the examples I used were, our fascination with dinosaurs. Why are we fascinated with dinosaurs? They're extinct.
Right.
They're gone.
Right.
Why do we spend so much time teaching our kids to be fascinated with large, charismatic animals? And which ones are we most fascinated with? The predators. T-Rex is not the biggest, but he's the meanest, right? We love blood and gore.
Right,
When I lived in Kenya for a year and a half, in East Africa, I became fascinated with the story of the Adamsons, George and Joy Adamson, who had adopted a lion cub. What happened was George Adamson was a conservation officer, a field type guy, and farmers complained that lions were marauding their cattle. So he went and he shot this lioness. Well, it turned out that she had 3 cubs that were orphaned. So George feels sorry for these 3 cubs. He takes them home, and he and his wife start raising them, bottle feeding them. Yeah. Two of them were pretty strong, and they decided to sell them to the Frankfurt Zoo. And the runt of the litter, the third one, they gave her a name, which was a mistake. They named her Elsa. And Elsa, as she grew up, she was obviously their pet, but she got bigger and bigger and bigger and started tearing up the furniture. And then they decided that Elsa was born to be free.
She was born free and she has the right to live free.
Well, how do you teach Elsa to live off the land if she's been living in your living room? And they took Elsa out into the wilds and released her and followed her and so on. And did that the experiences of the Adamsons tug at our heartstrings. And
Yeah.
they wrote 3 books about that experience. First one was called Born Free.
Mm-hmm.
A movie was, Hollywood got a hold of this because Born Free was top of the charts and the reading list. A television series was developed called Born Free. A song was written and it won an Academy Award.
Born free as the wind blows.
Anyway, the whole world was talking about Elsa the lioness. But at no place in the 3 books, in the movie, in the TV series, or the song, was there any reference made to how many antelope the Adamsons shot so that Elsa could live off the wild. To me, that was interesting. Here, our hearts were beating for the predator, and we thought nothing of how many herbivores the antelope were shot. Now, if our hearts don't bleed for the antelope, how are they going to bleed for the plants that sustain the antelope? You see this dilution of interest as we go down this food chain. I think that's fascinating. And it's wrong. It's wrong to then give so much attention to the predators and nothing to the primary producers. So, again,
you're going to thin the forest around my house. They've marked all the trees that they're going to cut down. I want to cry when I see a tree with a spray paint line on that because that creature is going to die.
Exactly. So that's the whole idea behind this, what I call Zeuschauvinism, an anti-plant bias and a pro-animal bias. And my animal ecology friends were a little upset with me using that term. And then I point out to them that within their own discipline of animal biology, zoology, they're not fair in how they teach about animals. Why is it that we have so many mammalogists on the faculty and we may have one, if any, insect biologists? And insects are much more abundant than the mammals.
Exactly. They're more species. There's more individuals.
I love to talk about these biases that we have because I'm all for biocentric equality, very much like social equality. Yeah. And we need to teach the golden rule as it applies to all species, not just certain select ones that we like.
Yeah, exactly. Yeah, not just Homo sapiens, but every species on the earth. And if we did have that, we would care more about when species go extinct.
Exactly. And if we had people truly understand how nature works, we would appreciate that we're dependent on nature. Yeah. There's an interdependence between humans and nature, and we can't afford to keep teaching that nature was out there simply to serve man.
That's exactly right. And, that gets back to what you were saying earlier, is that there is no separation between humans and nature. Humans are a part of nature, and we're not as important as we think we are.
Well, we are important, but in a negative sense.
Yes. Yeah.
So that's another area that I love to bring into that class and others, all classes. I like to talk about the lack of biocentric equality. I also talk about the biases that we have towards land organisms versus aquatic ones.
Right.
That's why, in my marine biology class, I don't talk about Earth. I talk about the planet ocean.
Right.
We're the blue planet, and we're mostly ocean. Yep. What do we use the oceans for? To dump.
Well,
stuff.
They're kind of our garbage dump, yeah.
That's our garbage dump. The attention of students that, hey, we use that for food supply. So how do you reconcile using the oceans to dump your waste, especially the nastiest waste you can think of, and at the same time fish out of there and eat whatever you fish for? It doesn't make any sense.
Yeah, it doesn't make any sense. You wouldn't make a sandwich on your toilet.
Exactly. That's what I say. And I've used that actually with students. I said, you wouldn't store your food in your toilet, would you?
Right. And they're probably like, oh, yes, no.
Yeah.
But that's what we're doing, really.
Exactly. So we have these biases that I like to talk about, we have a northern hemisphere bias versus a southern hemisphere bias.
Yep.
Because we're mostly land biased, and most of the land is in the northern hemisphere.
Also colonialism. Check out Jared Diamond's book, Guns, Germs, and Steel, for a convincing hypothesis that white supremacy exists only because of an accident of geography. Eurasia is the only continent that has an east-west axis, which gave advantage to those people, white people, who traded plants across long geographic distances. Basically, when you move plants and animals long distance north to south, they become ill-adapted to environmental conditions. But that's less of an issue for east to west movement. So, sorry, white people, it's just an accident that you've had the advantage for most of human history. You're not actually that special.
But then that gives us pause to ask questions that I do, like, what's the world's most abundant mammal? I ask students, and I get all kinds of answers on that one. And then they say, well, what are you driving at? And I said, well, I don't know this certain because we don't have good census work in the southern hemisphere, but the crab-eater seal that find all around the Antarctic, and that's a pretty big continent actually, is very, very abundant. I don't know how abundant it is, but I put my money on the crab-eater seal as being the most abundant mammal on the face of the earth. But that's my answer. I don't have proof of it, but right. I'd like to know just how many, what the biomass of crab-eater seals is, and compared to any other species in the northern hemisphere, I would still put my money on the crab-eater seal. Also, interesting. What's the world's most abundant bird? One of the candidates in my mind is the Wilson storm petrel. The petrels are mostly southern hemisphere birds. They're pretty common, but they're also very secretive. They nest on land, of course, but they're very secretive. They're nocturnal. And what do we know about nocturnal birds from the southern hemisphere that spend most of their time on and in the ocean?
Right. Well, not much.
Not much. So much about their numbers. We just know that mariners talk about how plentiful they are. And we know that they're pretty plentiful. We just don't know how plentiful. But anyway, that's where I put my money on the most abundant bird in the world. And we don't know about that because we have these other biases that we teach.
Right. I don't know if I ever told you this story. When I was taking biochemistry, we spent, probably 3 weeks talking about hemoglobin. And we used it as a model for enzymes and how, they attach to carbon dioxide and they're less efficient, but when they're oxygen and they're fine. And I was sitting there the whole time like, what about Rubisco?
Rubisco, for non-plant nerds, is one of the enzymes that makes photosynthesis happen. It sticks to carbon dioxide to bust it apart so that sugars can be made. Now, under certain conditions, it can also stick to oxygen, which cannot be busted apart to be made into sugar. So it's similar to hemoglobin in that way. It attaches to both carbon dioxide and oxygen. And this is important to understand because that's how those two gases move around in our blood, and most, but not all, other animals. Rubisco is way more abundant than hemoglobin, though. But we talk about hemoglobin way more because, well, Zeuschauvinism.
I actually give in that environment class and in talks that I've given, I actually give the students a little survey that I drew up, a one-page survey where I ask them things like, what's the most abundant protein in the world? And you can imagine what sorts of answers I get there.
Well, I remember one class that I was in, a girl said cow.
Beef. Yeah.
And I was like, what?
And you see these biases, and like your biochemistry teacher, the biases, spending all that time. I'm not saying studying hemoglobin is a bad thing, but to spend that kind of time versus other sorts of things that are equally or more important is, I think, a shortcoming.
Right. It gets worse though, Boz. It gets worse. At the end, we had our review before the final exam, and Clint raised his hand and said, how come we didn't talk about photosynthesis? And the instructor said, well, it's not that important.
Oh.
I almost threw a chair at him. Literally, Cynthia had to grab my arm and pull me back down.
And again, this is someone who should know better, but doesn't. And these biases are so overt that it just behooves us to bring to people's attention that we're not doing a very good job, especially when we're trying to understand how nature works.
Right.
And we have these biases that leads to a skewed explanation of how nature works.
Right. Yep. And that has really important implications when we're getting into, talking about how we're going to mitigate the effects of climate change. Well, if we don't know how things work, how can we do something to shift how it works?
Exactly. Yeah. Another one I asked in my survey, I asked students, what was the mode of obtaining food called before we began to wimpify, or domesticate plants and animals? What do we call that mode of obtaining food? And the answer always is hunter-gatherer. And I said, no, that wasn't the case. It was gatherer-hunter. And then he said, well, what do you want? And I said, hunting has always been a higher risk venture, something that the men did after they planned the hunt for 3 days and took another 3 to execute it, another 3 days to bring the meat home. In the meantime, the women would gather food, plant resources, something that we say is not important to sustain us.
Right, but it's like, okay, well, what was everybody eating for those 9 days while you guys were planning and executing and
There's now evidence that at least in some cultures, in the ancient Americas, women were great hunters too. Tombs were found of young adult women surrounded by weapons and skeletons of their prey. And speaking of biases, the researchers that discovered these tombs had a hard time arguing that these were hunters, rather than the wives of hunters or some bullshit. If the human skeleton was of a young adult man, well, I don't think that anyone would question his role in society.
Yeah, the amount of calories from plant and animal resources were certainly...
So our language is replete with these biases, and biologists are not immune from these biases.
Absolutely.
We use the word wildlife. I ask students, what does that mean to you? And obviously it means some predator,
Right,
and
exactly.
to me, I say it means a flower. And they say, oh, come on, that's not wildlife. Why not?
Why not? It's alive. It lives in the wild.
Yeah.
Yeah.
So much for biases in biology.
Yeah. People keep say that, science is unbiased, but that's bullshit. Like, everything, everybody, every field, everything has bias.
Right. And
if you can recognize that,
that's the first step in correcting inequality, recognizing that they exist, that these biases exist.
Yep.
We seem to have an insatiable need to create hierarchies. Biologists do that all the time. We also have such hierarchies created in our social construct. And this leads to inequalities, because when you start creating hierarchies, you
by definition, something has to be higher and something has to be lower.
And have a higher value, it seems. So the values are not equal. So that's the way we treat people as well as wildlife.
Wildlife meaning all life.
That's right. Yeah.
But I want to get your thoughts about what has happened to environmental issues in the last 4 years.
We've had our hands tied and our lips sealed at a time when just the opposite should occur.
Right.
All because of misinformation and politics. I went to the Scientists' March in Washington, 4 years ago, and Dennis Hayes, who started the Earth Day movement, he spoke, and he was almost despondent about the state of environmental awareness as a result of what was happening in Washington. And 4 years down the road, we're worse off than we were ever. So we've got to do a lot to recover yesterday, and it's going to take quite an effort. In a world of misinformation, it's become part of our culture to misinform. And the social media has, on the one hand, it's been great because you can find all kinds of answers to all kinds of questions. But
Right. It's
you
just
can also
whether those
find
answers are correct or not.
exactly, and that has set back education. It's frightening. It's very, in retrospect, we've lost a tremendous amount of ground, and it's going to take more than 4 years, I believe, to recover.
Yeah, absolutely.
From the last 4.
Yeah.
Because when something gets ingrained in the culture, it's tough. It's tough to deal with.
People are learning now. They're learning things that are incorrect, and so we have to de-educate them and then re-educate them.
Yeah. Undoing the mistakes is going to be very, very difficult and time-consuming.
Yeah, and I don't know if we're ever going to be able to get back to where we were.
Yeah. One could be pretty pessimistic.
Yep.
Climate change is a good case in point.
Right.
We don't have enough time.
Right.
Education takes a long time, and re-education is going to take longer. And we've got to make some decisions as a society fairly quickly.
Yeah.
And it has to be global.
Exactly. And do you know how hard it is to get people to cooperate?
Yes.
It's really hard. Well, we'll do the best we can, but it's kind of like there's not a lot of hope. I'd like to end this on a positive note, but there's not one.
Well, I know, but we have to keep trying, no matter how difficult.
Yeah, exactly.
And
because not only do our lives depend on it, and the lives of our kids and our grandkids, but the lives of ponderosa pine and the sunflower and the desert tortoise and all the critters, all the other wildlife.
Yes. Yeah.
In the life sense of the word, depend on what we do.
Exactly. Exactly.
So hopefully we can get. Yes, it is, and we can't just throw up our hands and give up, because I think that would be doing a huge disservice to society and our planet.
So we need to recruit more biologists, specifically botanists.
Yes, I agree.
So we can talk about photosynthesis in biochemistry classes.
That would be great. Yeah. So, Boz, in the last few years, I've worked a lot with high school students.
Uh-huh.
And I've had 2 students actually want to be botanists because of me. And so,
good.
And so really everything's connected. So those 2 kids that have decided to become botanists, they become botanists because of you. So. Well,
that's good to hear. And that's what's important. And that's, we want to end on a very positive note. That is what is positive. And that's what drove me to stay in this game for as long as I did, because there is hope when you look back and see how many people you've influenced and know that they can influence that many more. Education is the name of the game.
Thank you so much to Dr. Gene Bozinak, or just plain old Boz. Thank you to my high school students and their teachers that I've been privileged to work with for the past 4 years and counting. Music this episode is by Dr. Ron Deckert, who can be found on SoundCloud. A link is in the show notes. Not only is Ron the musical mastermind behind this show, he's also a researcher who studies plant-associated fungi. In the next episode, he and I talk about the usually helpful fungal friends hanging out inside of plant tissue. That episode will be released on March 3rd. Links to my sources are also found in the show notes. And please remember to tell a friend or an enemy to listen to the show.